Hello. So we're talking about similarity, and this is the way you actually show that two triangles are similar, is you use the little tilde, and that means they have the same shape, which means all the angles are the same, but the sides are different, and they're proportional. Something's been done. We've multiplied the numbers here by some number, a scale factor. Going this way, if we were going in the, we could also do it in the other direction and divide by that scale factor, or by multiply by some number that's a fraction, number less than 1. We can go in either direction. But if I tell you that these things are similar, then if I tell you this is 2 and this is 4 and this is 3 and I don't know what this one is, we can set up a proportion to figure out, well, what's the missing thing? And this assumes that we know that they are proportional, and I've told you that they are proportional or similar. So I know I can set up a proportion to do this. So we know that, so this is, I'm going to call this my small triangle, SM, and I'm going to call this my large triangle. So I'm going to say 2 is to 3, 2 over 3, so that's my small compared to my large, and I'm doing this because it's important that you set up these things right. If you set them up backwards, you'll get weird numbers that shouldn't even make sense. And then, so I know on my small triangle it's 4, and I'm comparing it on my large triangle to my x. So I got small over large, and over here I've also got small over large. If I flip those, I'll get some weird answer, and x will end up being smaller than 4, which doesn't make sense. We're getting bigger, so this has got to be a bigger number than 4, and also a bigger number than 3, since 4 is bigger than 2. Now you probably already know what this answer is, but the idea is that we can set up this for answers that are more complicated. And we use something called cross multiplication, which is a shortcut of multiplying both sides of x and then multiplying both sides by 3. And so what normally people do is say, well, I'm going to multiply these two because I know eventually I'm going to end up multiplying those two. And I'm going to multiply those two because I know I'm eventually going to end up multiplying those two. So I get 2x equals 12. And then our final step is to divide by whatever my coefficient is here. And that is 6, which is what I expected. I expected it to be bigger than 4, bigger than 3. And you probably already had figured out that it was 6. Now, I want to point out, cross multiply, which is what we just did, is not the same as cross cancel. Cross cancel is this. This is like, maybe I have a recipe that requires 2/3 of a cup of sugar, okay? And I'm trying to make a slightly smaller batch. I only want to make it for maybe 3/4 the size, so a slightly smaller batch. So if I multiply that by 3/4, this will tell me the right amount of sugar to put in this new smaller recipe. Now notice there's no equals here. In this case, I can do what's called cross cancel, which is like, oh, 3 and 3 both divide by 3. So 3 divided by 3 is 1, and 3 divided by 3 is 1. And oh, these both divide by 2, and 2 divided by 2 is 1, and 4 divided by 2 is 2. And so 1 times 1 is 1, and 1 times 2, and oh, I only need a half cup sugar. This is a different process. So make sure you understand what you were doing. Cross cancel, cross multiply is when you've got an equals and you have proportions on both sides. Cross cancel is there is no equals. You're multiplying two fractions together and you're just trying to simplify it by cross canceling. It's easy to get those mixed up and start, marking things out up here where you shouldn't be marking things out. Other thing that might happen is maybe I want to actually prove two things are congruent. So maybe I've got this triangle here, ABC, and another triangle, slightly bigger, that's DEF. And I am trying to prove that they are similar, okay? Well, if they've got all the same angles, they are similar. I may not know the scale factor, but I know for sure that they are similar. So if I know this is maybe, 30 degrees, and this is 90 degrees, and I know this is 30 degrees, and I know this is 90 degrees. Now, we know what this is going to be now. And it's going to be 60, but the point is I don't even have to know that that's 60. If I know two of those angles, the 30 and 90, this third one has to be the same. So the rule here for saying that these two things are that triangle ABC is similar to triangle DEF, the rule here is AA, just AA. If you write AAA, it's not necessarily wrong, but typically we just say AA, because if we know two of the angles are the same, the third one has to be the same. So we just call that AA. It's not AAA technically. It's just, you could figure out that third angle, there's an edge. So that is one way to prove two triangles are similar. Another way to prove two triangles are similar is, once again, let's say I have ABC, and I have DEF, and I'm trying to prove that they are similar. So I'm going to do that with a little question mark over it. Maybe I've got a side and a corresponding side, and a side and a corresponding side. Now, if I knew these sides, and right now it looks like my scale factor I think is 1.5, okay, then that's one way to prove it, and that's our third way. But maybe I just know this angle. Maybe I just know that this is, 25 degrees, and I know this is also 25 degrees, or they're just both marked as being congruent. So these are congruent as long as these numbers are proportional. So I have to actually check that. So is 2 over 3, so small to large, the same as 4 over 6? Now in this case it may be obvious that they are, but it's not always, and this is why we have to check it. If we've got weird numbers there, we have to check it. Now here's the easiest way to check it. We're going to cross multiply again. Because if these are proportional, this times this, 2 times 6, has to be the same as 3 times 4. That's kind of our rule before. And so that's 12 is equal to 12. So in this case, they are proportional, but you have to check those numbers. And this is known as the side angle side similarity theorem. So it's a little bit different than regular side angle side because these sides actually aren't congruent, but they are proportional. So we have to check proportions or proportionality. We have to make sure that 2 over 3 is the same as 4 over 6. And if these numbers come out as different numbers, then they're not proportional. And I'm going to show you an example of that. Okay, one more. So once again, we'll stick with our letters because we like them. A, B, C. Terrible pictures, D, E, F. I'm trying to prove they're similar. Okay, so let's say I have 3, 4, 5, and 6, 8, 10. Okay, so oops, you can't see that. So in this case, maybe they kind of look like the same shape, but in this case, I need to make sure the scale factor is the same for all these. So I need to check that each one of these is proportional to the other. So I need to say, well, is 3 over 6 the same as 4 over 8? And is 4 over 8 the same as 4 over 8, the same as 5 over 10? And is 3 over 6 the same as 5 over 10? I need to make sure all those proportions are the same. If they are all the same, then these are congruent, not congruent, similar triangles. So once again, 3 times 8 is 24, 6 times 4 is 24, so that checks. 8 times 5 is 40, 4 times 10 is 40, so that's checks, and 6 times 5 is 30, and 3 times 10 is 30, so that checks. So this is known as, these are proportional by what's called side, side, side. And once again, this is not the same side, side, side as congruence, but it is side, side, side in that I've shown that all the sides are proportional to each other, or in the same way that they all have the same scale factor. You could probably even look at that and say, well, they're all scale factor of 2. And that would be another good argument to make if you were trying to prove that. Let me show you one more. Let's try that one more time. So I'm going to start with my 3, 4, 5 again. And I'm going to call this G, H, I. And make another one. I'm sorry, the triangles are terrible. Let's get a little tricky. 7.5, 9, and 12.5. Okay? And we'll call that K, L, M. And I'm trying to figure out if those are similar. So that's my little symbol with a question mark over it. Okay, so I'm going to set up, is 3 over 7.5 the same as 4 over 9? And is 3 over, and somebody's knocking on my door and it's going to mess me up. Okay, we're going to try it again. 3 over 7.5, that was right, small to large, is 4 over 9. And is 4 over 9 the same as 5 over 12.5? And finally, is 3 over 7.5 the same as 5 over 12.5? And I'm going to put question marks on all of these because I'm not sure. Okay, so 3 times 9 is 27, and 4 times 7.5 is 30. And I can stop right there because that's a problem. I could check the, it may be that I need to check these others because maybe these others will work out. But as soon as I get one that doesn't work, I'm like, well, those two sides aren't proportional. This is clearly not right. But you may have to check all three before you find a mistake. So these are not similar. Okay, thanks.